Good morning, Brigade, visitors, and distinguished guests. My name is Midshipman First Class Chesley Krug, and I'm a computer science major here at the Naval Academy. This morning, it is my pleasure to introduce today's first panel discussion. This morning's panel will address how artificial intelligence is revolutionizing industries, products, and core capabilities. A wide variety of technologies are considered artificial intelligence. These technologies range from fully autonomous systems to less ambitious solutions that make no decisions on their own, but rather allow analysts to understand large amounts of information. We are fortunate to have an esteemed and knowledgeable group of panelists with us this morning to discuss how artificial intelligence is and what the future of AI will look like. Panelists will discuss concrete applications of the technology, as well as explore the limitations, ethical considerations, and examine how humans and intelligent machines will and currently do interact. Moderating this morning's panel is Dr. Gavin Taylor. Dr. Taylor is an associate professor here at the United States Naval Academy and is the co-director of the Naval Academy's Center for High Performance Computing, Education, and Research. Dr. Taylor is an active researcher in a variety of areas within the field of machine learning, to include reinforcement learning, the behavior of neural networks, data poisoning, and distributed optimization. Dr. Taylor received his bachelor's degree in mathematics from Davidson College and his master's and Ph.D. in computer science from Duke University. Ladies and gentlemen, please join me in welcoming Dr. Taylor and this morning's panelists.
Thank you very much. Let me start by adding my thanks to the Institute and to the sponsors of this event for letting us do this. As somebody who's enthusiastic about artificial intelligence and who's enthusiastic about the things that we're trying to do and that we are doing in this field, it's a really exciting opportunity to gather people together and talk to some interested folks about what it is that we're doing and why we care. So when I first started graduate school in 2006, I needed a new car. And I told my now wife that I believed, as a go-getting young graduate student in AI and machine learning, I was sure that the next car that I bought would be fully autonomous. I drove that car for 12 years. Didn't happen. Didn't happen. So a commercial, fully autonomous vehicle is not yet available. If you ask a Tesla engineer, they'll tell you that they're almost there. If you ask a lawyer, they'll tell you that they're absolutely not. But at any rate, it's not available yet. But what I was able to get in my inexpensive new car was it will keep me inside the lane lines, it will prevent me from rear-ending the car in front of me, and it will monitor my alertness level as I drive on a long drive to let me know if I should stop for a nap or a cup of coffee. So while we don't yet have a fully autonomous vehicle, my drive is safer and more comfortable because of artificial intelligence nonetheless. Oftentimes, this is, of course, how progress happens. As we have large dreams, we're going to solve these massive problems. But there's waypoints along the way. Interesting points of, in this case, less autonomy and more assistive to humans that are extremely helpful, that are extremely beneficial, and that can be achieved in a shorter amount of time and with fewer resources. So we're fortunate today to have a very esteemed group of AI experts to help us understand how AI is advancing along that continuum, from assistive technologies to full autonomy, and how people are learning to adapt to that advancement. Furthest on my left is Dr. David Aja. Dr. Aja earned his Ph.D. in computer science from the University of California, Irvine, and started working at the Naval Research Labs shortly thereafter. He has been a successful and respected member of the research community ever since, making major contributions, especially in the fields of case-based reasoning and explainable AI. Next to me is Dr. John Beeler. Dr. Beeler is the Director of Science and Technology at the Office of the Director of National Intelligence. Before that, he worked at IARPA, where he focused on machine learning, human language technology, and vulnerabilities in AI. We're very fortunate to have Dr. Beeler with us today. Ms. Solis, who appears in your program, had a family emergency, and so we are very glad to get somebody as qualified as Dr. Beeler to be with us today. On my other side is Dr. Reza Ghanadan. Dr. Ghanadan earned his Ph.D. in electrical engineering nearby at the University of Maryland and has had great success applying AI and machine learning to real-world problems in a variety of positions, including at DARPA, Boeing, and a startup he founded called Flarion Technologies. He is currently a senior manager of cloud AI at Google. And finally, on my right, Rear Admiral Brian Losey served 33 years as a Naval Special Operations Officer, culminating as commander of the Naval Special Warfare Command. Since then, he has leveraged his operational experience to guide AI development as a partner in Shield AI, a company that provides AI and autonomy technology to the Department of Defense. So we're very excited to have this group for you today. So I want to jump right into the questions. We're going to talk up here for about 60 minutes, and then for the last 30 minutes of this panel, we're going to open it up to questions from all of you. So if you have something in mind, please write it down so you don't forget it, so we get to answer your question. Okay, so I'm going to start over here with Dr. Eha. So you've been a member of the AI community for 30 years. So you've seen this boom and bust process of AI happen a couple of times. As this community has met with success over the years, and as we think about this continuum, has that caused us to generally dream bigger as sort of we have these achievements so we can think about bigger and more exciting problems? Or are people starting to find places to slot in today's AI into today's problems?
So I believe that the advent of deep learning has allowed us to dream bigger because all of a sudden we have the opportunity to be able to reason with sensor data. That's very encouraging. That begs the question as to what are the remaining challenges with respect to using deep learning for these tasks. And they're well known. So some of them were covered earlier. We have to worry about adversarial inputs. We have to make sure that the system isn't misapplied. We have to make sure that it's properly situated in the context in which it's supposed to act. The question you posed, in part, was with respect to what is the context that we see ourselves today. And I've been heavily influenced by my interactions with DARPA and its efforts in what's known as the third wave. So by the third wave, what DARPA refers to is a succession of time periods and foci of AI. The first wave that they describe is that of what really was the second wave of AI, which was of expert systems. And the second wave they describe as the advent of statistical machine learning, which is most of where we are today. And we're trying to push beyond that. And the third wave they describe is that of contextual adaptation. So in this context, with deep learning gets so much press, it begs the question, how can we ensure that these systems that are being attempted to be deployed today can be deployed in such ways that they're very much aware, self-aware of their context, and they can leverage the models that they should in order to be able to perform and behave as we expect them to. So having said that, part of your question was with respect to trends. While there is trends to dream bigger, there's also continued trends to focus on relatively narrowly defined applications of AI, as we've seen with respect to games, browsing, things of that nature. We'll continue to see these trends as we move on.
Thank you. One of the things that you mentioned was adversarial inputs.
Yes.
I expect that's going to come up a few times.
Yes.
Could you define that term for us just before we move on?
The way I like to define it is that for those who have studied machine learning, one of the first things that they're familiar with is specifically with respect to the topic of supervised machine learning, in which the data that you're given are labeled, is that you understand that the data all comes from typically a single distribution. And that's key. So adversarial inputs are those that lie outside of that distribution. The most common example that we see today, in which no doubt you've seen in the popular press, is that of an image that has been modified ever so slightly with respect to the pixels. And it looks the same to us, but looks very different to the machine. What's happened is that because of the modification of the pixels through adversarial inputs, all of a sudden we're taken out of that initial distribution. Whenever we're asking the system that's trained on one distribution to be able to act properly on on something that's outside of that distribution, we're in trouble. So adversarial machine learning is all about trying to take advantage of that.
Okay, thank you. So Dr. Beeler, you're here representing the intelligence community. I think everybody is a little bit curious about how is AI benefiting the intelligence community. In particular, you have all these analysts there. Is your goal to replace those analysts, or is your goal to assist those analysts in their jobs?
Yeah, first, we never replace analysts, ever, never, ever. So first off, thanks for having me here, and thanks for everyone in the crowd for having me here. And as was mentioned, I'm standing in for Ingrid, so hopefully I can have as interesting and dynamic as she is. You were promised her and got me, and for that, I apologize. So what are we doing in the community with AI? So go back a few years, and our former Principal Deputy Director of National Intelligence, Sue Gordon, came in and took a look at the community. She's a career intelligence professional, and had an idea about where do we position the IC for 2025. A few years ago, that sounded very far away. Now that is very close, right? But as part of that kind of look that Sue took at the community, she saw that we needed to do a few things, right? So we need to do things like change the way we acquire, change the way we work with our workforce, the way we partner with the private sector, and then one of those things was what is now called AIM. It's called Augmenting Intelligence Using Machines, right? Notice it specifically doesn't say AI. The AI does not stand for artificial intelligence. So really, to your point, we're looking how do we augment the human intelligence that we have in the community using machines. And machines, not just AI, but automation, augmentation, and artificial intelligence, right? Because we don't always need a deep neural network to do something. We might just need a Python script to help someone that is having to look at a bunch of Excel spreadsheets, right? So that's where we're at. We have this big IC 2025 initiative called AIM, and as part of that, we're trying to drive forward the community, right? Because for those who might not be familiar, the community is made up of 17 agencies, including the ODNI, right? So we have the big agencies that everyone's probably familiar with, CIA, NSA, NGA, so on and so forth, but also all the service intel components, Department of Treasury, Homeland Security, they're all members of the US intelligence community, and what this initiative is trying to do is figure out how we drive forward as a community writ large. And as part of this, we're really trying to address our mission imperative, because fundamentally the business of the IC is in both its data and its product, and the goal is to provide actionable intelligence to policymakers and a time frame that they can react to, right? So if we figure out what's going on, but it's after the thing goes boom, right, that doesn't really help our policymakers. So we need to be ahead of those actions. So this is complicated by the immense increase in data and the velocity of data that we have, right? The former director of NGA, Robert Cardillo, said up in public that given the current pace of collection at NGA, he would need to hire 8 million imagery analysts to keep up with the daily take, right? We're not going to hire 8 million imagery analysts to keep up with the take, so we have to figure out something else, right? We have to figure out how to address these needs, or else the kind of business of intelligence as we know it is done, right? So that's really what we're driving forward with the AIM initiative, because that's particularly addressing GeoInt, but this is true across all our ends, right? So to say one more word about what we're doing with AIM, we're organized across mission initiatives, right? So this is things like cybersecurity, indicators and warning, identity intelligence, so on and so forth. But then we also have foundational initiatives, which is things like, anyone that's trained one of these neural nets knows you need a bunch of compute time, you need GPUs. We also need data, right? We mentioned supervised training where we have labeled data. We need labeled data, right? Just having the data isn't enough. We need data that's usable. We have lots of policies and security things that happen within the community that we need to address to make these things widely usable. And then we said a word about adversarial examples. We also need some measure of security and reliability. So one of the foundational pillars of the AIM initiative is AI assurance and AI security. So how do we have a measure of trust and assurance and reliability in these algorithms as we deploy them forward to operational settings? There's a lot more to say about the AI assurance and security, but I think we'll punt that to a later discussion and not take up too much of the air in the room.
Okay, yeah, thank you very much. So we work our way down the line and give people a chance to introduce themselves, if you will. Dr. Ghanadan, you've had a really interesting career. You've worked in a lot of places in a lot of different positions. So you've worked at DARPA, you've worked at Boeing, you've had a startup of your own, and now, of course, you're at Google. have you found that there's a difference in the kinds of problems that a Google, which is trying to make money and is trying to solve something today, is trying to solve, versus the strategic elements that the government is trying to pursue? Just have you noticed a difference in the investment between those two sides?
Sure. Thanks, Gavin, and the organizers of the event. It's a wonderful event, and the Academy and the Institute and all the participants. Yes, I had a great pleasure and honor to work at the government and at the DARPA with a unique experience. The focus of the DARPA, of course, as a mission, is to prevent any strategic surprises, technological surprises, prevent Sputnik moments, if you recall that, and also invest on more strategic, pivotal breakthroughs for the national security. And that mission is taken very seriously by all the members of the DARPA. We work very hard to identify really challenging, important problems. Again, strategic, longer term, sometimes next 5, sometimes next 10 years. As you know, internet would not have been possible if it wasn't for that investment. And the networking, computer networking, and many other technologies that we use easily for granted. And many businesses that are based on that have been flourished. That obviously creates certain technologies, and the important aspect of it was to bring a lot of communities, a lot of teams from the industry, from the startups, from academics, from government, just bringing all these teams together, the best possible teams to actually tackle these challenges. Mm-hmm. And that was very important to DARPA. And it's something that quite important to keep in mind. Really working on DARPA hard problems, typically our benchmark is like, can you make another internet? Yeah. Or 10 times more powerful than the civil art in that technology. Of course, the flexibility in government is very unique because it doesn't have to be, teams don't have to be worried about tying it to revenue, to profits, to products, both short-term or long-term. And unlike businesses where in all companies there's a fiduciary responsibility to the stakeholders, to their shareholders, and making those profits and be able to have a good business. That both, some of them decide on a shorter term focus, some long term. At Google, we cherish both. There are a lot of strategic technologies that we work, and a lot of more immediate ones related to the product, making them safe and reliable, and providing access to a large platform. It's also important to realize, in case of Google, the mission of Google is to organize the world's information and also make it useful and accessible to users. Those two are really important. Making it useful is really, really important, and making it accessible to a large, as you know, hundreds of millions of people and billions of people that use different applications, from maps to YouTube to search, and many other applications there. I have seen some more focus on the platform. I think having a unique platform that be able to provide computational, very high speed and very a great deal of computational capability to users and to Google developers has been very, very fundamental. That also provides a very large user community, being able to access it across the globe, and be able to help testing new ideas in potentially isolated ways, and then expanding the horizon from there, and then improving it. So as you probably have seen, many of the applications that were launched, over time, they got better and better and better. And AI has been very important in improving those. I mean, can you imagine Gmail and your email if it didn't have a spam detectors? We really hardly see a lot of that.
Right.
Now. That's a very important way to be able to improve the user experience. So that's another aspect that is very heavily vested at Google, user experience. Which, by the way, government is certainly very focused on servicemen and public to be able to have that experience as well, and designing requirements to meet that. Sometimes I have seen in some of my experience in the past, that chain of requirement gets lost, where the user really wanted to what at the end was delivered, and part of it perhaps was the lack of interoperation and open access. How quickly we could go and test, develop a new innovation comes in, quickly be able to test it, try it, and deploy it. That, in some of my experience, I thought that was very difficult and of course, very expensive.
Yeah.
Like could be one performing team or company had total access to be able to do that one change in a line of code in, let's say, F16 or any other platform. Very, very expensive. But also, it was a heavy emphasis on reliability and be able to have a solid performance on many of these platforms. That was really key. So there are trade-offs of how we can manage and how we need to deliver these. At Google and also at government, throughout my time at DARPA and at Google, there's an extremely amount of emphasis on privacy, on responsibility, a sense of being able to deliver reliable systems, fairness and unbiasedness, how to prevent them. Those were very, very important issues, and everybody is really very focused on that.
Yeah, I'm glad that you brought all those human aspects up, because we are going to circle back around to those. I think those are really interesting and really important. So, thank you. Admiral Losi, so you had an interesting transition. So you spent a career as a Navy SEAL, and then you retired and became a partner in an AI company. How is it that the Special Forces have used AI in autonomy? And what is it about your Navy experience that led you to believe that this was the area that you wanted to be in?
Well, thanks, Dr. Taylor. And I'd also like to thank USNI and the Naval Academy for allowing us all to be here. I want to extend my thanks and appreciation to you all for being here and the difference you're going to make. And I want to double that for the midshipmen. I promise you, you will not be bored in the coming years. And I'm so thankful that our future's in good hands. So just to be clear, our AI is not just about special operations. It's not just about DoD even, although that's the focus of our enterprise Shield AI. We became involved in AI out of a concern. One of our founders had some battlefield experiences where, basically we're losing a lot of folks by encounters with the unknown, not knowing when we enter a house whether hostiles are going to be there, and not really being able to adequately discern whether there's threats before we encounter them. And that's how we incur most of our casualties. So the idea was, can we use autonomy? Can we use edge AI? Can we use AI for maneuver to mitigate risk to operators, to reduce casualties, to increase mission effectiveness through the promise of what AI is and what everybody hopes that it will bring? I think that is the core mission of what we do, and that's our specialty area. So to be clear, we consider autonomy to be a part of AI. Tim Cook at Apple had said that autonomy is the mother of all AI problems. And so when you think about full autonomy like we talk about it, we're talking about drones, robotic maneuver systems that don't need RF control, they don't need a pilot, they don't need a GPS reference, they don't need any a priori knowledge or experience or programming to encounter an unknown environment and to perform its own OODA loop, to perceive the environment, to cogitate what to do, and then to act, both singly and in organizational elements, multiple robot formations. So that is the part of the industry that we're in. There's a tremendous amount of academic research that's out there, but how do you distill that? And this is one of the big challenges. There's so much engineering genius out there. How do you distill all that capability into something an operator or warfighter on the edge can use? And that's, when you look at the concept of the company, we're basically a cross-functional team of entrepreneurs, predominantly software engineers, a small slice of hardware engineers because we're a software company, and a small cohort of warfighter and folks with policy-making experience to help navigate some of the uncertain waters. One of the greatest risks of AI is that we don't lead it. If you're concerned about national security in the future, then it is imperative that the United States lead AI so that we can unfold the best practices, so that we are not driven by superior AI to assume additional levels of risk when it comes to lethal actions. If we're not in front, then we will incur a tremendous amount of additional risk. And it's that first adopter advantage that you all read about, that Microsoft had, that Apple had, that all these companies with aggregated capability over decades have such a dominant position today. They had that initial first adopter lead. And so this is what we seek to do in the autonomous maneuver community. Just as a sort of a measure of what it is we do, our stuff's been on the battlefield. We use some shortcuts. They're approved, they're legitimate, but they're not traditional fielding processes used by DoD. They're more akin to what the Special Operations Forces use. So our systems have been on the battlefield in Iraq, Afghanistan, and other places in the hands of operators conducting human-machine teaming. Just as a simple measure of speed, and speed is not the only metric, but it's one metric. If you take a 4,000 square foot building with about 20 rooms in it, for a single entry point, one robot going through one door, that's about a 2.5 minute problem, roughly 3.x meters per second in speed. If you take a fully trained 9-man clearance team out of the special operations community, that's about a 7.5 to 8 minute problem to move through that. That's on a single entry point, and you can only do entry points that are where your fields of fire are aligned. You can do opposed entry points with unmanned drones and autonomous systems and cut that in half again. So right now you can see that without even really aiming for speed as a measure of effectiveness, we can autonomously clear an unknown building nearly twice as fast as a trained clearance team. So I'll just stop right there. That's kind of where we are in the industry space and what we're about.
That's really interesting. Thank you very much. Okay. So there was a lot that came up there about when we're in this assistive technology space and when you're in a human-machine team, how do the people interact with this system? And one of the big questions, of course, is do you understand what it is that your system is doing, or the idea of explainability? Dr. Beeler, you mentioned quite a lot about your all these image analysts. You need somebody to help them do their job. How important is it that a system that they're using be explainable, be understandable, as opposed to just it's right almost all the time, so who cares how it works?
Right. So great question, and kind of explainable AI is a big topic in the community. We were talking about the DARPA Explainable AI program in the green room before we came out. I take a slightly different stance, which is explainability is important, but it's just one part of a broader concept of trust. Right? How do we have human analysts, or in the case of the warfighters, teaming with machines and have some notion of trust? You can draw some sort of weak analogies, which is like if you're driving a car, you have 3 points of control, right? You have a steering wheel, gas pedal, brake pedal. You don't know everything else that goes on in that system. You no longer know it's no longer wires, right? But you don't know how it works. But you still trust that when you turn the wheel, the car will move. So this is what we're really trying to get at, is how do we engender some notion of trust between human analysts and machine teams. So this includes things like failing predictably, right? So it doesn't have to be perfect all the time, but if it fails, it needs to fail in a manner that's understood by the person. When it gets things right, there needs to be some notion of why it got that right answer. Part of this is the whole reason we want to use machines, and we moved away from some of the expert systems earlier in the AI realm, is that we couldn't encode all the human knowledge, right? So if we could, cleanly articulate why these things are the way they are, we would be in a rule-based system. So part of this is I'm happy to embrace some of the unexplainability and black box notion that come along with deep neural networks. And that's just one thing, it was mentioned earlier, right? Not all of machine learning is neural networks, and largely when we talk about black box and explainability and things like that, we're talking about neural networks. Right. And there's a far broader space of machine learning solutions that we can deploy other than deep neural networks that can get around some of these things. And then the final thing that I'll say on this is the kind of trade-off between explainability and accuracy and performance, right? Anyone that's ever had to deploy one of these technologies operationally, whether in the government space or in the commercial space, right? If you're Google and you're having to run, millions or hundreds of millions or billions of inferences, every day, you might not have the most performant algorithm, but you need one that is able to keep up with that speed. So there might be another trade-off for us here, that we might not have the most performant algorithm, but we have one that's more explainable and more trustworthy. So this is, in the kind of parlance of the IC, that we need to establish the tradecraft around the algorithms that we have and the tradecraft around what we deploy forward, right? And where these trade-offs and where these decision points lie. Mm-hmm. And we just don't have a ton of this basic science around that right now, but this is where some of the great research and some of the basic fundamental research investments are coming into play, so that we can start getting to that point where we have the science and we have the understanding.
Right. Okay, so Dr. Eha, I know this is one of your focuses of research, and so I want to come back to you and have us define how it is that we even do this. But first I want to put it up for a jump ball over here, because you both have customers who are using your autonomous and your AI systems. How important is it in your experience in providing products for others? How much do they value explainability versus correctness?
Yeah, maybe I'll go first. It's extremely important. We found it important in several dimensions. Of course, it was mentioned describing it. It goes back to a large part to the trustworthy and establishing that trust. Many products just cannot be used and launched if people don't trust using them. One component of it is correctness, performance. Mm-hmm. But every time we work, and of course at Google, we really work on augmenting using AI and augmenting humans and the users, not replacing the decision-making process. So every time there is a black box in a decision-making process, it just makes it difficult for people to trust it. Doctors, if there is a recommendation system telling them, okay, there's a cancer potential with 80% chance, they would like to know what caused that, what was potential causing that decision, not causing a cancer in this case, but understanding what were the important factors in priority that led to that recommendation. Yeah. It's also very important to know, be able to communicate that to the patient, not to the doctor only. So anytime that you augment and help people, the question of psychology and even cognitive sciences, that area comes in, which at Google we take that very seriously, right. Working not just software engineers and machine learning and AI scientists, but also psychologists and human user experience researchers that actually be able to communicate and understand what that explanation means. Yeah. And we have developed tools toward that. So TensorFlow has a number of tools that some of them are active research, some of them are available. For example, showing in an image or a video, what are the pixels that led to certain decision or recommendation. Yeah. That's a good example. Or using natural language processing, what part of a speech or language translation potentially was at fault in translation. Right. There's a number of examples to be able to even go all the way to your training data set to highlight what are potential examples that this algorithm learned from and now led to this decision that you're seeing. Yeah. So those are kind of help interpret the underlying decision-making process. But we use it also all the time for being able to do test and verification. I don't know, some of you may not have the background knowing, we're moving from a traditional coding a lot, shifting it into data-driven codes. So unlike having a logic building an algorithm that is in the code where we know its behavior very well, mm-hmm. Now we're shifting to codes more and more in complex systems that you just have a sort of training data. Mm-hmm. And directly go from this training and raw data or labeled data into a code. Now, we need to understand how this code behaves and using explainable tools and more interpretable models and approaches help understanding, verifying the behavior of this system, but also being able to, over time, really improving the performance.
I don't know if my students look forward to that kind of debugging more than the kind I'm making them do now or not.
Yeah. That's really a great point. Debugging for all the coders is really, really important. We also see in examples like, in regulation, we have in finance and also medical field, healthcare, you just cannot pass just go by the performance accuracy. Some are, areas, from a regulation perspective, they just don't allow using a model that is not enough interpretability there to understand, like next drug recommendation, or even why credit is not granted. We could go there. Some banks are happy to see understandable models with an accuracy of, let's say, 60%. But they're not just authorized to use a higher performing models if they cannot explain why some of these underlying techniques. So performance is important, but it's only one factor in the real life, real world applications.
Right. Admiral, are you finding that to be true as well?
Yeah, I think contextually the answer would be it depends, always. So again, the distinction here, we're talking about an edge maneuver system in the hands of soldiers, Marines, first responders, and the like. What we tend to do is ensure that they know what the operational envelope and what the TRL, technology readiness level capability is for what we're putting in their hands, because it's the nature of people to push the envelope to find out when it's not going to work. Okay, so first we have to establish the boundaries of what the known capabilities are and give them confidence in that regard. We have very high confidence. So to kind of give a little detail on that, if we're to do 100 runs on that 4,000 square foot building I talked about earlier, the robot comes in on a single entry point, 77 times it'll go left, 23 times it'll go right. Is that a failure, or is that something I should be concerned about if 99.5% of the times the robot gets through the building with sensors on all the areas that it can access? To us, that is success. If somebody has concerns about, I don't know why it went right or left that time, we can dig into millions of lines of code and go through the ROS bag and figure out, okay, what was tripped in a certain sensor that caused it? Was it an angle of approach on the entry? Did a body move through? Did a puff of dust pop up? What were all the variables that caused that? We can dissect that, but in the broader scope of things, in this environment, 99.5 of the times it accomplished the designated mission. I will tell you, when you go to some of the special organizations in DoD where they have the luxury of kind of circumventing the HR process and keeping teams together for decades at a time, where you develop a habitual training relationship and you know instinctively what your partners are going to do. Even on a good day, if you're batting 65 or 70%, you're out at the park. Okay, in terms of understanding human behavior and, did the teammate have an argument with their spouse? Did the dog die? The cat, is in the vet? What's going on with their teenage daughter? And there's all these things that create to the stew, but yet you still flow through the problem. For those kinds of tasks, when you use artificially intelligent and enabled systems, you can come up with a much higher degree of reliability, where instead of relying on a bunch of different humans, you can have one sergeant first class or one senior chief on an iPad interface doing finger swipes for macro commands to control multiple robots. So we understand the concern about reliability, and we're intensely focused on making sure that envelope that we define is bulletproof reliable. But then there's so many use cases where we haven't encountered the use case, and we have to classify the behaviors, eliminate the bad, reinforce the good, reissue the algorithm, and go back out. But this is the beauty, the promise of AI, right? Is the progressive improvement of capability over time. That piece hasn't been fully realized, I think, yet within the procurement system and how DoD acquires systems. But when you field something that's immature and expand its operational capability with not a whole lot of additional investment, any more than you would for a Microsoft license to operate Windows. Okay, so these are the sorts of things that we are encountering out there, different issues that we have to work through. But yeah, reliability is a concern that can be addressed.
Okay. Yeah, thank you very much. So Dr. Reha, one of your main areas of research is this idea of explainable AI.
Right.
One question I have is how When you say, as a researcher, I build explainable AI, what does explainable mean in that context?
Oh, okay.
And second of all, when you emphasize one thing, it seems like you are necessarily de-emphasizing other things.
Yep.
So is there a trade-off when you say explainability is important?
Right.
Does performance go down?
Right. So first, by the way, you mentioned debugging earlier, and so my role is as the evaluation team lead for the DARPA Explainable AI program right now, which is about halfway through its lifespan through April 21. And there are a number of teams amongst the 11 performer teams that are actually working on debugging as a focal task. So it's interesting that you bring it up. I'd be happy to talk about that. So XAI is commonly thought within the AI sphere, as opposed to the social sciences sphere, of the capability to be able to provide insight on decisions and the models in AI systems that are responsible for those decisions. Note that I did not say machine learning in that phrase. XAI is much bigger than machine learning. Having said that, although there are efforts in AI planning, reasoning, intelligent agents on XAI, most of the work that's being done today is, in fact, by far, on machine learning. And that's what the DARPA XAI program is all about. It was misnamed to some degree. It could be argued. It should have been called XML. So Dave Gunning, the program manager who conceived of the XAI program, was able to characterize the types of XML approaches in 3 ways. First, he noticed that there was a lot of work, or there was some beginning work on the topic which he called deep explanation, which was the modification of deep learning algorithms in order to be able to support explainability. For example, some of the work pertains to analyzing a network once it's been learned or trained to convergence. A second way is to be able to reason about the types of explanations that are delivered, be they in one modality or another, text, for example, or visually. A second category that he noted was that of interpretable models. They do not use typically deep learning approaches, but what they do bring to bear is a model of the domain that is in a form which can support explanations from the get-go. And the idea is to be able to integrate that with the learning algorithm in order to be able to support those capabilities. The third way, and maybe most intuitive, is what he referred to as model induction. And this goes by many names. It could be mimic learning, for example. And the idea is that I've got a black box. I'd like to be able to understand what's going on there. And I've got an alternative approach that better supports explanations. So what I'll do is I'll query that black box ad infinitum, get the outputs, and take those input-output pairs, if you will, and be able to provide them as training data to my white box model. So I can then use that model and pray and hope that it's well aligned with the black box model to provide explanations. Okay, so having said that, you asked about trade-offs. What I find from talking with all the teams is that there is a hot debate going on right now in the machine learning community on whether or not a trade-off exists between 2 axes, and they are the axes of machine learning performance and explanation effectiveness, as I like to call it. So the concern is that if we introduce capabilities for XAI in these systems, are we sacrificing something in machine learning performance? The view of the machine learning community, as I understand, is that yes, because they're thinking in a very theoretical perspective, and they're saying if we do things such as we introduce certain loss functions that favor explanation, we are almost guaranteed to sacrifice in terms of machine learning performance. This is not my perspective. This is not the perspective, and I must admit I'm influenced by UC Berkeley Professor Trevor Darrell when he talks about this. So consider that explanations are never one shot. They're always in the context of interaction with someone else. I might try and explain something to you, and you say, wait a minute, you didn't explain that to me. I have some more questions, and we follow up. Explanation is a process. It's an interactive process. During that time put, there are at least two involved, right? The explainer and the explainee. And the explainee is providing additional input to the explainer to guide them as to what type of explanation they need, to provide additional background information on the subject, et cetera, in some cases. That takes you out of the typical constraints that are discussed in the theoretical constraints and perspective of the machine learning community. So in that regard, it's not clear. And in fact, I would argue the trade-offs are not well known between whether or not sacrifices need to be made in machine learning performance in order to be able to support explanation effectiveness.
Right. Just another thing that's not well known. Yeah.
It's being studied.
Right, right. Yeah, thank you very much. So this conversation about how people interact with our AI systems has a number of different angles. One of them is how is it that that person and machine team is effective? And the other is, are we using these new powerful tools in the way that people would like them to be used? In particular, as we work our way along this continuum from systems that just help people do what they're already doing better, all the way up to systems that are making their own decisions, at some point it seems that there needs to be a discussion about the ethics and the legal framework on how it is that these systems are used. So Google is one of the lead drivers in AI in this country and doing research. Is there a worry about sort of boiling the frog here, where as you work on smaller, more assistive technologies and work your way up, that we miss this ramp where we say, we really should have thought about this by now? Do we have an ethical and legal framework for this? How does Google deal with this question?
Yeah, that's a very good question, very important question. And as we all have discussed, AI is very powerful, very transformational, could impact many, many lives and products to improve lives going forward. It has obviously raised questions, and that powerful technology brings responsibility to address the responsibility, the ethical, the fairness, the issues from security, safety. A lot of these range of questions that are very important, and we do want to make sure those are addressed properly. Google has developed a set of responsible AI process and tools that you're welcome to search for that, and it's on our website. We take that very seriously. Everything we do at Google does go through these checkpoints, either products and also customers and the use cases. Those are reviewed very, very heavily. And the case by case. And every time even the same thing is used and another use case very similar to that, we reopen the questions. So there's a very healthy discussions that has to go on. The technology aspects of it is active research, and these questions takes time to develop together with the broader communities to be able to answer them. Some of them is based on really how do we test, for example, for fairness and biases that exist in the raw data, and we do not want a platform to magnify those biases. So it has to be checked where our customers and users use these tools, be able to address it with a set of tools and technologies that we have developed. It's an age of what we call deployed AI. It's not, the whole potential. We have seen more than 80% of many large businesses that work with us across the globe have seen that they really want to use AI, but unfortunately they don't know how to use it and apply it.
Yeah.
And how to use it and make it responsible, the process is a big part of that. And the tools to help them, be able to help them to make that decisions is very also important. Yeah. We have some of that process. For example, we have AI hubs that we were wondering whether it's useful to have. So there's a lot of our tools are available on this AI hub. And the community also, from academics and companies and customers and users, contribute to that. But we wanted to know, well, is this going to be checked against the process we do internally for our work, but how about for those users that are out there using it? So we came up with two-step process there. One is to actually have the community be able to provide feedback and have a conversation around every one of those tools that are available in our AI Hub. Engaging the community, we see that very, very important. And then look into our process and make sure that those are meeting our internal process, and if they are not, being able to address them on our platform. So as I mentioned, platform is very important, processes is very important, tools are really important, and we are dealing with all of that with active research there.
Okay. And then Dr. Beeler, I was curious, your take on that same question, on the ethics and legality of this. Yeah.
Right, awesome. So the first kind of note to hit on this is that within the US system, right, the power of innovation and our ethical principles is what we really think is what gives us an advantage over our adversaries. So it's imperative that we bake those ethical principles in from the very beginning to any AI machine learning technology that we deploy forward. And so with that said, just to kind of foot stomp what I was saying earlier, that we're really in the analyst support realm, right? So our question's a little bit less sticky than, DoD problems of autonomous weapons and things like that. So we're really looking at data triage problems to support analysts. And kind of to that point, what we're really focused on is one of the kind of crown jewels of the intelligence community is analytic tradecraft, right? And our analytic standards that we know and are able to uphold the products that we develop and send to policymakers. So what we're working on now is similar tradecraft around AI machine learning. How do we bake these things in so that they're moral, legal, and ethical, follow the laws, policies, and statutes of the United States, and what's that tradecraft look like? And additionally, we're working with our Office of Civil Liberties and Privacy to develop a framework of ethical principles. That's not out yet because we're really trying to take our time and make sure that we get it right and not just crank something out and send it across to say we have something, but really get to the root of what does it mean to have an ethical application of AI machine learning. And kind of to the point earlier, this is still up in the air for industry, for academia, so we're wanting to make sure that we get this right and get inputs from various sectors and corners of the community to generate these ethical principles. So that the kind of key takeaway there is the tradecraft around the use of AI machine learning, and then our ethical principles and our ethical framework for the usage.
And so what are as you're developing these frameworks, what is the questions that you're asking the most about as you go through that process?
Right, so we're debating about a lot of the things up here, right? How explainable does an algorithm need to be? Who does it need to be explainable to, right? Where does the kind of decision point lie? Is it with the data scientist? Is it with the senior manager? Is it with the director of national intelligence? Who's responsible for these things as they get deployed? What's the reproducibility, right? So we say tradecraft. If you're kind of a scientist, you would just say good science, right? So if we're doing hypothesis testing type stuff, can you reproduce the experiments that we use to get to this algorithm, right? So these are the sorts of questions so none of this is particularly new in terms of kind of philosophy of science type things, but really we're trying to figure out how it fits in the current moment. And that's why I mentioned we're talking a lot with industry and academia to say, how are you thinking about some of these things? Because again, really, really open questions like we heard about explainability and things like that. So this really is a new frontier, and my experience has been every time we start to ask one question, it really just brings up 3 or 4 others. So it's kind of a never-ending process and never-ending quest, but we're getting awfully close to kind of a finalized set of principles, and those will be kind of completely unclassed and completely open. We'll publish them on the DNI website so everyone will be able to see kind of what we're thinking our kind of ethical principles for the use of AI ML are.
Okay, very interesting. So I think that is our first hour, right? So we have another half hour left of time with you, and so we would love to take some questions. So there's a microphone there, and there's a microphone there. If anybody has a question, I encourage you to work your way. Sir, if you're loud, while folks are making their way to the microphone.
Sure, this is directed at Naval, but I'd be curious about how you can follow up. You said that these national security risks is not being versed in AI. What are some good metrics to evaluate whether or not we are versed in AI?
I think looking across the continuum, I mean, AI is almost like the new CT, right? Everything is AI. There's not much distinction sometimes between automation versus autonomy. The conception of AI in the U.S. government context is largely static analytics as opposed to maneuver out of the concerns of killer robots or lethal autonomous weapons and all that goes with that. I think the biggest indicator, the most visible indicator, will be as if we're outmaneuvered in a warfighting situation on the battlefield using a combination of autonomous systems in our adversary ground and combined arms forces. That's going to be the most visible manifestation. When we look at AI, we talk and we think in terms of decision advantage, not in terms of lethality. I mean, we clearly understand and acknowledge Department of Defense's role in warfighting and how lethality plays in that. But I would offer that perhaps we don't have as great a problem in inducing lethality as we do in inducing it in precisely the ways that we need to achieve our objectives. Okay, and so we tend to focus on bigger and faster OODA loops, the ability to aggregate greater amounts of information more rapidly and process that information into sense making, and to be able to tune those processes to optimize on the signatures that we're looking for. Okay, the most visible manifestation is going to be when physical comes in contact with physical. I would offer that static analytics behind the walls of an intelligence agency or a governmental building where bureaucratic decision-making processes will take the output of an AI rendered, this is our understanding now. Are we going to flip that into our normal decision-making processes? Because I would say that undercuts a significant degree of what you gain in terms of decision advantage if you trust your algorithms. Okay, and this is the imperative, again, moving forward rapidly, failing fast, learning your lessons so that we can gain the decision advantage. Okay, again, the lethality piece versus the decision advantage piece is a very clear-cut case. When you look at hypersonics, just as another example, that is an increase in lethality. That is a compression of decision space. Okay, so if you don't have your decisions mapped out and you're dealing in double digits of minutes to make critical decisions, and you're dealing with things, other next generation warfare type combined arms capabilities, fake news, deep fakes, decrementation of infrastructure, financial infrastructure, all these things that seek to hit the core of the real center of gravity, which is the will of the population and the will of the nation, that is where decision advantage becomes critical. And when we don't have decision advantage and we're forced by other people's decision advantage to assume greater levels of risk and unreliability because we're not in front, then we have a challenge. Okay, so there's all kinds of pacts. There's a Paris call right now for everybody to get together and have standards of how we deal with cybersecurity. You saw in an earlier presentation this morning where a bunch of luminaries from industry, from academia, and basically transformational industries are saying, no AI for lethality. We only sanction good use. But yet, if you understand that most of the algorithms, particularly for maneuver, they have to be developed synthetically. It takes tens of thousands of iterations to run through an algorithm or a maneuver stack to make sure that it will function before you translate it into the real world environment. Yet you saw one of the luminaries, who I'm not going to name, but Defense of the Ancients. Defense of the Ancients is one of the great strategic games out there, warfighting games out there, and a subsidiary company of one of the signatories to that, we will not use AI for lethality, has a war game where AI is beating. Now, I would tell you in that decision-making space, that's probably an area we ought to be looking at is how do we make sense-making out of all the different sections of information? That's already happening. So let me conclude on that point by saying AI or technology is not good or bad in itself. It's people and what they're committed to and how they want to use that technology that will either increase casualties or reduce casualties. And you can see this through millennia warfare. Just look at chain guns. Advanced technology used to increase lethality rates. Okay, look across millennia and see how technology, from first offset to second offset to third offset where we are today, and just kind of go, we can choose to reduce casualties, and this is what, as an enterprise, we do when we're in a competitive market space for talent. Okay, we cannot go out there, advertising that we're about increasing lethality. We're about reducing casualties, reducing risk, increasing precision, making better decisions to attain our political end states. Just look at a generation and a half of war, Vietnam. Okay, 10 years of warfare, 60,000 casualties, a limited conflict. Okay, not unlimited warfare, which seeks the utter annihilation of your adversary. And then take that to a generation and a half later, Iraq, Afghanistan, Horn of Africa, and all the other places we're engaged, a conflict that's been going on for 20 years that has produced about 6,000 casualties. So twice as long, 1/10 the casualties, 1/20th the casualty production rate, because we are committed to greater levels of precision. And this is the kind of language that we use when we're trying to bring in top-level talent to say, we can reduce, if you commit to it, we can reduce casualties, unnecessary casualties in warfare to zero. We can attain our objectives with less waste and less pain. And that's the kind of thing, those are the manifestations, you know, are they going to be realized yet? I don't know, I just kind of extrapolated for you. I can tell you what I think the visible manifestations are, but just from my background, I don't think that things that happen behind closed doors or in static analytic constructs are going to be as easily discernible. And I think we're going to lose a lot of that if we don't have trust in our algorithmic reliability in terms of making decisions, and we have to take those outputs and put them into our bureaucratic process, then we're going to lose on decision advantage. The Russians already are around this. President Putin is the interagency, right? He doesn't have to go through the interagency process and balance bureaucratic equities. The Chinese don't have any barriers between business and government, okay? And they're also less stymied by interagency. But, you know, de Tocqueville said, this is the beauty of our governmental system. And so we have to learn how to play, and I think the only way that we can play effectively is by being out in front.
Thank you. And then I'm going to come over here next, but before I do, I just want to add that if no midshipman asks a question today, I'm taking it out on my students tomorrow. Sir.
Thank you. Can you speak briefly or at length to the level of effort we're devoting to data handling as opposed to collection and algorithms? Because it seems like we're lagging in our scale, speed, volume issues.
Jump ball.
Yeah, I could add a remark on that. So thanks for the question. I think that's a very, very important question. We work with a lot of enterprises, again, as I mentioned, and we have seen the number one most time-consuming part is data handling. Is the pipeline and the data that collecting them, curation, making sure it's labeled accurately for supervised learning, if that's the method we want to use, and how, what are the biases potentially in it? Is it going to be leading to an algorithm that will be fair in its modeling and prediction and inference? That's a very, very important, and we have tried and continue working actively to provide that in a platform that for customers that come in, how to go through that process. What are they trying to do? What are the metrics? The users, talking to them very patiently and actively understanding what are the users really need and where AI could help, and then finding the right data to actually go. So cleaning the data is really, really important. Because as I mentioned, the shift going toward data-driven codes and data-driven models starts with data, and that's really important to be clean and curated.
To hop on that, from our perspective, I mentioned these IC 2025 initiatives. One of them that is closely tied to augmenting intelligence using machines is modern data management and infrastructure to address exactly this question, which is, traditionally, we've had a ton of data, we've tagged it, but we've tagged it for access and need to know, right? So this is now looking at what do we need to do with our data handling and our data management, our data curation to enable some of those technologies that we've been talking about today, and that's a kind of big, weighty question for us because we have legacy systems. We have to be careful with how we do this because of our sensitive information, but it is something that is deeply under consideration, and we're marching forward towards making sure that our digital infrastructure is positioned in such a way that it can support the things that we're talking about today.
Thank you.
If you take it from a more to the edge, the DoD-specific construct, you're looking at, how do you ensure data assurity, the security of your data, not just how it's labeled, but how it's not been tampered with. Then you have to consider joint operations across the services in multi-domain environments. So how do you make sure that that data standard is appreciated by all? And these are some of the challenges. We're able to do isolated experimentation or isolated demonstration, but to be able to get to a coherent command and control architecture and then operate in an environment that's both distributed, interrupted, and limited, so the adversary gets a vote in how much information we're able to push across networks of networks, and then you start to really get a more complicated problem. So I think those are the crux issues when you look at in the warfighting context or Department of Defense implementation. And I don't speak for the Department of Defense, I speak from a marketing side of a company that's trying to get a toehold in the market.
Right. Thank you.
Maybe I add just one more quick remark. So because data is so expensive and hard, we also, you could imagine in some of the application it's hard to find the right instance of the data. Maybe an object that just doesn't exist as much, or an event. Let's say a driverless car, you want to learn how to avoid an accident. You don't want to send a human driver to the accident and actually keep trying to learn a million times. So that's the idea of synthetic data and augmented learning that we work also very heavily on research and tools. And synthetic data will help generate the necessary data to augment the real data that is collected, especially for rare events, for safety, for controls, and be able to have a reliable set of tools to be able to use.
Good morning, gentlemen. Midshipman Second Class Ingle. My question is to the entire panel. So obviously with the development of these open source AI, things like TensorFlow that's Google's doing, there's the threat of independent actors developing very powerful technologies. But how do we know that the technology isn't developing itself? Are there safety checks to leverage where we know that the machine is doing what it's saying it's doing?
Interesting. It's a big question.
Yeah.
So,
Please.
So there's maybe 3 baked in there that I heard. So, 1, independent actors, right? And the first, you saw this with the company OpenAI released their language model GPT-2. And they did a limited release of that model, right? So they didn't release the full pre-trained model because they said, we think that this language model is too good at generating new text, and we think it can contribute to this fake news, fake media. So we're going to hold some of that back. We'll release a limited model, but not the whole enchilada. And so that's, I think, probably the first time that's happened in the machine learning space that a company or entity has said, we're not releasing all of our trained model. So that's kind of one consideration to this acknowledgement that maybe open sourcing everything isn't the best move. That same company, OpenAI, is concerned with making sure that artificial general intelligence is safe. My slightly snarky answer is that I would love to have that problem. Right now, a colleague of mine, Mikel Rodriguez from MITRE, always jokes, he's a computer vision guy, and he always jokes that it was just 6 years ago that he was no longer embarrassed to brief out the results of some of these neural networks. So we're still really focused on making sure that the kind of machinery works, and we're not kind of to the self-replicating phase. And the final thing that I'll say is that the kind of AI assurance and AI security, we mentioned data tampering and data poisoning, we mentioned adversarial examples. So AI is really just another threat vector akin to cybersecurity, right? You can do all sorts of attacks. You can make the machine do the wrong thing, learn the wrong thing, or reveal the wrong thing, is the kind of taxonomy that we've assembled. And we want to make sure that we're secured and robust against all of those. The analogy that we draw is this is like the 70s and 80s when we were developing networks, right? And it was largely research projects, and we were linking things together. And now, 30, 40 years later, we look back and say, oh no, we've done it all wrong. So now we're trying to make sure that 20, 30 years from now, as we have deployed AI technology, we don't look back and realize that we've done this all wrong. So we don't have all the answers to those 3 problems that I outlined. It's very nascent science, but we're at least having the conversation now so that we have an eye on the ball so that we don't lose sight of things as we move forward. So, but great question, and again, very, very big question, so excellent.
Yeah. So again, very, very good question. Since you mentioned TensorFlow, so one of my colleagues have analyzed the softwares that what we use internally, and all of them use TensorFlow, and only about 10% of them were the actual machine learning code. And there's a huge amount of software and code is written around it about monitoring, about some of the tools that could help understand what the model is doing. That's very, very crucial to be able to see whether is it really doing what the user has asked it to do. An explainable tool is by the way, one way to address it partially. I would say there probably your question is two. One is on the adversarial side, how adversaries could abuse them, and several people mentioned that, which is very, very important. And then the other part is just like very hard to tell a machine what a human wants, right? That's a kind of value alignment. Professor Russell actually has been working on that issue, and we are very interested in that as well. How do you tell a machine reasonably what you like? And if you miss a few things along the way, mathematical algorithms tend to, during optimization, tend to take some of these parameters to extreme values. That's why the example in how some of you have seen the movie, it goes and actually kills some of the people or doesn't respond to them because it's going after this optimization that somebody programmed it as the real goal. So it's important when you're communicating the goals, what are the full features that you like? And by making it easier, how do we do that? That's a really technology question, value alignment, learning the reward and utility functions in the AI loop. But the adversarial side is also very serious, and there are methods to prevention against adversarial machine learning and also against some of the false media, how to detect those. So those are active research that we're working on. And TensorFlow, we're providing a lot of these tools on that TensorFlow platform for the customers to be able to prevent these. And one of the tools with the AutoML is built in. Some of these things become built in to be able to make a more robust metrics. So instead of deep learning, sometimes blindly, data scientists go and optimize for performance, for maximize accuracy, but they only can test it based on trained data and available data that they collected. The question is, can we find other metrics supplementary to look at the variance, not just the mean and the maximization, but the variance? And that's in government is really important, right? We a lot of times say, this is military spec. You expect it to be really doing really well in this variation of, let's say, temperature or size. So variance is very important, and also how the distance, what we call L infinity, which is really the robust metrics in that optimization. If you do real world variation or adversarial attacks, how much is this system going to be still giving you the the right result?
Yeah. Thank you.
Thank you.
Good morning, gentlemen. Midshipman First Class Anik. Can innate human bias be programmed into AI? And if so, at what point in the process would we realize that it's there?
That's a great question. I think probably a lot of folks have answers to this. Yeah.
I'll be happy to.
Yeah, please.
Yeah, and so biases, that was the question, right? In the data. So it's really important not to design an algorithm and then magnify it to millions of users. We have noticed that in some of the early customer adoptions of even providing credit, for example, and loans, because a lot of data that gets collected, and these are, let's say a bank may have collected the data based on what they have really have done over time, but they didn't realize and they know that there were biases in the portfolio and the data that they had collected. So that gets built in to these algorithms and then they get magnified. So we want to prevent that. And some of the methods is to be able to look at the data, the raw data, and during the curation process, look at its balance, finding the various features that stand out. We have a process to help with that, but it's active research to make these fair and take the biases out. We have had even in, biases in maybe not in unexpected ways, like, if you're detecting even certain cars or certain things, some colors do not show up. Or even we were asking questions, if you go for a search and rescue and you want to use a visual detection, certain colors do not jump out. In some areas of security, that could be a potential issue. So we do try to first extra analyze, test and test and test. Use sometimes synthetic data to be able to balance and bring the data that was missing or fill in the area that we're potentially making the algorithms more accurate in certain data points toward that bias, and be able to average it without hurting the performance in some of the categories that we're supposed to do. So we found balancing is very important, and synthetic tools would be helpful and a way to fix those. But it's an active really research.
Dr. Aha, you must have a fair AI group.
So the question was, under what circumstances do we have human bias in AI, and how do we know it's there? The answer is it's always there. Because from day one in our studies, we knew that we were sampling from a particular body of data and not outside that. So we know that whatever the system, typically we're talking here in the context of machine learning, whenever the system's learned model can do for us, it's always going to be only competent with respect to the data that's given. So if the data reflects any types of lack of information pertaining to a subject area that we want the system to perform well in, we'll recognize it. But the way to recognize it is through systematic test and evaluation strategies, in which you want to ensure you've got great coverage over all the expectations of the users. And by systematically testing throughout that entire space, you should be able to discover many of the biases very quickly. This extends not just to machine learning, but also to intelligent agents and other topics within AI as well.
Quickly, and I won't say too much, because I saw Michael Kearns on the agenda for this afternoon, a professor at UPenn who has done a ton of great work. So my other advice is ask the same question of him, because he will have some really great insight into this.
Yeah.
My name is Peter Pennington, and in case you can't tell, I'm a Brit. My question parallels that last one. How do you protect yourselves against coding prejudice?
Yeah.
So since other people said things, I'll pick the thread back
please.
up. So I think, again, the common thread of the previous answers is that we're not coding per se, right? Because we're not coding like a program, we're learning from data. So these things are baked into the data themselves. So that's why with some of the word-to-vec and word vector examples, you saw, that man was more closely aligned in vector space to doctor and woman was more closely aligned to nurse. It's not because someone programmed that in, it's just they took, all of the Google Books corpus and that was the learned alignment. And the kind of reason for that is the goal that we tell these algorithms to pursue is accuracy, right? Get as accurate as possible and ignore everything else. So it will make some seemingly dumb decisions to gain greater accuracy. And that's why I was saying that Dr. Kearns has done great work on this to say, how do we bake in other objective functions into algorithms so we can learn other things besides just accuracy while still learning accuracy. So a lot of this is on the statistical machinery itself, and there's a lot of good work going on in the, I think they call it now the FATE community, because it was previously FAT, Fairness and Transparency in Algorithms, and now I think it's Fairness and Transparency.
Accountability. Fairness, accountability.
Yeah, there you go.
Yes.
Yeah, and explainability is the E. I think.
Yes.
Yeah, so turns out FAT wasn't a great acronym.
So my sense is that this gets back to DevSecOps, and that what you need to do is to ensure that these prejudices are caught early. So you have to have everybody at the table at day one, your policymakers, your TVV experts, your end users, your domain experts. all working together to ensure that issues such as this prejudice that I do believe does exist, and it goes beyond just the data, are addressed. That's going to require domain experts in the algorithms themselves that the developers would tend to use, and they have to make sure that it's explicit as to what the biases in those algorithms are, so that decisions can be made by the entire development group as to the reasons to employ some of them and not others.
Yeah, and may I add also, of course, I totally resonate with what was said here, and we talked about this data-driven and codes and shifts, which is all those contribute to that, and we need to prevent it. But we also see, obviously, this is as helping human decision makers, as augmenting humans. And by doing it, one major reason is to actually give more time back to analysts or decision makers to do higher level reasoning and thinking. And that hopefully provides more time and tools to the human decision maker to watch for these biases, prejudice, and issues that may be available from the beginning in the data or in the practice, and that could be very different in different societies, different application and use cases. But that's one of the help that could provide these tools, not to fully automate and then blindly use them, but have human decision makers in that loop and at the end of decision making.
Yeah. Thank you. One more question? Okay, sir, thank you.
Gordon Rogers, Worldview Holdings. How and if are you anticipating things like information theory laws vis-a-vis Shannon, even if like Drake's equation, where it's a complicated thing addressing things like prejudice and other things, are you anticipating general information theory laws to apply to this arena?
What was the very end? Apply
Do information theory like laws apply to this arena, in your opinion?
I'll say something quick because that resonates. My last program at DARPA was inspired by work of Shannon. It was called Fundamentals, Limits of Learning, or FUN LOL.
Shame on you. Shame on you.
And it was really inspired to be able to, for those in the audience that may not know, Shannon really was the father of information theory, and still today, that was more than 50 years ago or longer at Bell Labs. And still today, anyone who uses a communication system uses the Shannon limits and things that coding and other things that he has developed. So we do, to some extent, use information theory. We haven't seen a fundamental as clear what Shannon has done in communication, but from a point of mutual information, is very, very helpful in our online learning. Let's say, how do you evaluate information, a new piece of information that is introduced, maybe a new phone? Is that something, a new information in that new product? Because you don't know its product, by the way, right? So it's a new information that now your online algorithm, let's say for shopping, needs to learn, or is it not new information? It's based on some previous information, you already have that. And if it's a new information, how much weight you want to put into adjusting your algorithms in an online to make the online algorithm more accurate. So adaptation, information theory comes in the factor there. And then there are a few other things that we are looking in. What would be the content of information and how also protection against it.
Thank you. Great question.
I just want to thank our panel. We're going to have to cut it here. But I want to thank our panel for a superb discussion and thank Dr. Aha, Dr. Beeler, Dr. Taylor, Dr. Ghanadan, and Admiral Losi. This is a superb discussion, got into a lot of topics that I heard before the conference that people wanted to hear about, and we really appreciate this. So let's give our panel a big hand. I've got a book for each of our panelists, which I'll give out, but meanwhile, for our audience, we're about to take a 30-minute break, and we've got boxed lunches in the lobby for lunch, and we'll reconvene at 12 o'clock. Thank you.